Welcome to the first video of the module 3, that is partial differential equations. In this video I am going to give the introduction about the partial differential equations. So in the partial differential equation we have formation of the partial differential equations by using the two methods. The first method is eliminating the arbitrary constants. And in the second method, we are going to eliminate the arbitrary functions. Let us discuss some problems and how to eliminate the arbitrary constants. So in order to eliminate the arbitrary constants, before we must know what is P, Q, R, S and T. P stands for dou z by dou x. That means the given function, if it is differentiated once with respect to x, that is dou z by dou x, we will be getting P. And if it is differentiated once partially with respect to y, we get Q. And twice with respect to x, it will be R. Once with respect to x and once with respect to y, it is S. And twice with respect to y gives us T. So before eliminating, we must know these symbols. So first of all, we will consider the first type, that is formation of the partial differential equation by eliminating the arbitrary constants. First problem, form the partial differential equation by eliminating the arbitrary constants. Here the arbitrary constants are a and b. When we consider 2z is equal to x square by a square plus y square by b square, we need to differentiate till we eliminate the constants. First, let us differentiate partially with respect to x, treating y as a constant. Then, twice of dou z by dou x is equal to 2x divided by a square. Then, thus we know this dou z by dou x can be written as p. Therefore, 2p is equal to 2x by a square. Dividing 2 throughout, we get a square is equal to x by p. Next, let us differentiate with respect to y, treating the x as constant. Then, we get 2 dou z by dou y is equal to 2y by b square. That is 2q, because dou z by dou y can be also written as q. Therefore, 2q is equal to 2y by b square, or b square is equal to y divided by q. Now let us take the first equation, that is the given equation, where we are going to replace a square and b square, which we have obtained now. 2z is equal to x square divided by a square, where a square is replaced with x by p, plus y square divided by y by q, that is b square is replaced with y by q. Then we get x square p divided by x plus y square q divided by y. Cancelling y and x, we get 2z is equal to xp plus yq. This is the required partial differential equation wherein we have eliminated the constants a and b. Similarly, we have another problem, that is x square by a square plus y squared by b square plus z square by c square is equal to 1. So this, I am just giving you the hint, that is differentiate equation 1 partially with respect to x, treating y as a constant, again partially with respect to y, treating x as a constant. So this way it can be proceeded. I will not be solving this problem. Next, how to form the partial differential equation by eliminating the arbitrary functions. Here the function is f, g, h, etc. like this. In this equation we have f as the function. So the given equation is z is equal to y square plus 2f of x 1 by x plus log y. First, differentiate one partially with respect to x, treating y to be a constant. Then we get dou z by dou x is equal to 0 plus 2 times of f dash of 1 by x plus log y into derivative of 1 by x with respect to x will be minus 1 by x square plus 0. And we know that dou z by dou x can be written as p. Therefore, p is equal to minus 2 times of f dash of 1 by x plus log y divided by x square. Now, let us differentiate the given equation partially with respect to y, treating x as a constant. Then we get dou z by dou y is equal to 2y plus 2 times of f dash of 1 by x plus log y into 0 plus 1 by y, because the log y derivative is 1 by y. Thus on simplification, we get q minus 2y is equal to twice of f dash into 1 by x plus log y whole divided by y. So, dividing the equation 2 divided by 3, we get p by q minus 2y is equal to 2 times minus 2 times of f dash of 1 by x plus log y by x square whole divided by twice of f dash of 1 by x plus log y. Cancelling the f dash on both numerator and denominator and also 2, we get p divided by q minus 2y is equal to minus of 1 by x square divided by 1 by y. That is, p divided by q minus 2y is equal to minus of y divided by x square. Cross multiplication and simplification gives us px square is equal to minus qy plus 2y square. That is, taking the terms consisting of p and q on one side, we get px square plus qy is equal to 2y square. This is the required partial differential equation wherein we don't have any function. Thank you. In the next video, I am going to discuss the next topic, how to solve the homogeneous partial differential equation as well as non-homogeneous partial differential equations.